Okay, so let's talk about modules, packages, and pip in Python. So the first thing is, what is a module? Well, a module in Python is basically just a .py file. That's basically it. There's nothing really extra that you need in order to make a module. Basically, all a module is something that has functions, variables, classes, and all these kinds of things. So basically just a .py file. But typically, it's good practice to keep your py files, your module short and also relevant. You don't want to have too many classes in a single file, and you especially don't want to have too many unrelated classes in the same file. So typically you want your modules to be kind of focused on a specific problem that you're trying to solve, and to be short and concise, to the point, to make your code as neat as possible and as short as possible. So why do we use modules? Well, modules allow us to make code more manageable, more scalable, and basically allows us to containerize code, make code more, basically just more concise. With modules, stuff is like just easier to debug and it's less error prone. And this is because working with a single file that's short is a lot easier than working with files that are hundreds of lines long. It's also way more organized and less cluttered. Each module, what's important to note is that each module is like an independent unit. You should try to minimize the number of dependencies on other modules, because in the end, you want a module to be kind of this one thing that can do its function perfectly. And basically, that's the whole purpose of using modules, to make code concise, manageable, and independent. So a good analogy is to imagine modules like these cargo boxes. Each of these cargo boxes alone has its own kind of things associated with it, its own body. But together, they can work together, be shipped on different ships. They can do stuff together, but still they're all independent units. And this is why it's a decent analogy for using modules. So once again, how do we use modules? So, like we said, all a module is a .py file. So far, every time we created a py file, we've been working with modules. The import keyword, which we've used before, allows us to, well, import or use other modules. Essentially, from, let's say in this case, I have this main.py module, I can access the mod.py module by basically just importing it. If they're in the same folder, it'll work fine. So you can just say import mod, and Python will find this mod.py file and basically allow you to use its code. And as you can see here, we call mod.py, and this dot notation, this dot operator, is very important because it allows us to kind of call members from this file. So from the mod file, we have this pi variable, which is equal to 3.1415. And by calling mod.py, we're just getting that value. Similarly, we can call the function add2nums, which will get this function. It'll execute this function, passing in the values 10 and 20. You can also have this class dog, which can extend the animal class. You could just do a lot of stuff with modules. It just allows you to kind of make your code a bit more concise rather than having everything in one file. Okay, so like we said, to call members from a module, what you have to do is you have to reference the module name. In this case, which is mod, and then just use the dot. We've already used modules before. For example, the random module, we've used that extensively. So you should be fairly comfortable with importing. We've also touched upon the from and import when dealing with the random module as well. And essentially, what the from import syntax allows you to do is import just a specific member from a module. So rather than importing the entire module and having to reference it with mod.add2nums and mod.py, instead, what we can do is do from mod import just the function add2nums. And so later, instead of referencing with mod.add2nums, all we need to do is just reference the name add2nums. So this is useful when you're using this add to nums functions a lot, and having to type mod dot at the beginning is a bit tedious and can make your code a bit more messy. So in that case, this from import syntax might be a bit useful. And we have seen this before using random and the shuffle members. So we said from random import shuffle, which allowed us to call shuffle, the function on, for example, a list or something. Okay, so now what are packages? We've talked about modules. Well, what are packages? Packages are simply like a group of modules. So you can think of it being like a folder, whereas modules are like the files themselves. Packages just allow you to group modules together. Packages can also contain sub-packages. So basically you can think of this as being nested folders in your directory structure. What's important though is for Python, in order for Python to know that the current directory is a package and not just any random folder, you need to specify an init.py, a double underscore init underscore .py file in every folder that is a package. So in this case, you can see we have a big package, which is the math package, which defines its own init.py. That's how we know it's a package. Inside it, we have 3 sub-packages: algebra, calculus, and trigonometry. And inside each of these has its own init.py, which is also why we know these are packages. And each of these sub-packages also have their own modules. So the algebra package has algebra mod.py. The calculus module has calculus mod.py, and the trigonometry module has trigmod.py. And each of these are modules, whereas the folder themselves is a package. And this is called a directory tree or a directory folder structure. But tree is typically what a lot of people will use to kind of like refer to this kind of directory structure. So essentially this special init.py basically just tells Python it's a package. Typically this file can be empty, but there are times where you'd want to add some code to it, which we won't get into today. Okay, so we've talked about how you create your own packages, but what's the point of that? Well, the thing is, other developers have written hundreds of useful packages, and that are basically free for you to use. So most of these packages will be hosted on PyPy, which is a very useful site. It's called the Python Package Index, which basically has a ton of different packages that you can use in your code. Basically, these packages are code written by other people, which can allow you to use pre-written functions, pre-written code that'll make your life a lot easier. You can install these packages on your local machine and basically use it like you had written it, as if you had written it. You can, in order to install these libraries, these packages, what you need is a tool called pip, which we'll get into in a moment. And this is typically done from the command line, even though IDEs can help. So if you're using an IDE, you may want to research how to use it, but we'll be using it from the command line and talk about a few commands that are useful for doing stuff like these. So the first thing we want to talk about when dealing with pip is virtual environments. So what is a virtual environment? So when you start up your computer, you just are basically working in your home computer, your root directory. But typically when you're working with Python, anything you install, you don't want it to directly affect your computer. You don't want it to be accessible everywhere. You kind of just want to have it local in this one environment. And another use case of this is that if ever you want to send this environment to somewhere else, you don't have to worry about any stuff that are installed elsewhere in your computer because everything is just local to this one virtual environment. A virtual environment basically is just, you can think of it as being this kind of, everything is local inside this virtual environment, and all code is installed, all dependencies are installed inside this virtual environment, and everything that happens in the virtual environment stays in the virtual environment. So it's not technically directly affecting or being installed on your computer, but it's useful when using stuff like pip because everything is just local, and anytime you want to ship it somewhere, you want to send it to maybe a different computer to do stuff, it's just all convenient in one place. Okay, so we're going to get into a few terminal commands in order to set up a virtual environment. But a quick disclaimer is that you don't really have to worry too much about the terminal commands because the next few slides aren't mandatory to understand, because virtual environments, you don't absolutely need them to work with Python. It's only useful when you are working with modules and packages. And also, many IDEs, like for example PyCharm, a very popular IDE for Python, well, sometimes you can very easily set up a virtual environment in these IDEs. And if you are using an IDE and you'd rather do it that way, you may have to do some research into how it's done in your specific environment. Anyway, if you're also interested in this VNV package, which is used to basically create a virtual environment, you could check out this link right here. Basically type this URL in and it'll take you to the website where you can install this particular package, which will help you set up a virtual environment. Okay, so the first thing when you want to create a virtual environment is you have to start up the command line. So I already have this set up, as you can see here, and I've already gone into a directory. For Mac users, you can use Spotlight to open up the terminal. For Windows users, you can go to the bottom search bar and type in CMD. And for Linux users, just do it however you would normally do it. So the first thing you want to do is you want to go to your project root. And for those of you who are a bit more fluent with the command line, you'll know that this can be done using the CD command. And some of these commands that I talk about might be platform specific, and since I'm using a Mac, the commands will be for the Mac, but some of them are platform agnostic. But if they aren't, you may have to research. If it doesn't work, you may have to research what the equivalent is on your operating system. Anyway, once you're in your directory, all you need to do to create a virtual environment is this command right here: Python-m VNV, and then give it some name. Typically, the name you want to use is, again, VNV or just env for environment. Doesn't really matter. But another caveat is that if you're on a Mac or a Linux device, you may have to type in Python 3 -m, whatever, instead of just Python. So I'll do that. I'll do Python 3 -m VNV, and then you could use some name. In this case, VNV. And if I do that, it'll take a moment, and Python will do some stuff behind the scenes. And now, if I open the Finder, you can see that now we have this VNV folder created. And this VNV folder was because it's called VNV because I gave it this name, VNV. So I have this folder, and what's in it? If I go into it, you'll see it has a bunch of stuff. This is stuff that Python automatically installs when you run this command. And this stuff is helpful when installing stuff like pip, because it'll basically just allow you to store all your information in this one spot, and it's just easier to manage. Okay, so now that you have a VNV, you are done. You basically have set up a virtual environment. It's literally that easy. You have one command to type, and now you've set up this virtual environment. And what's important to note is that this command is only run once. And typically this is when you first create a project. You do not run this command every single time you run a Python file or whatever. You only run it once. And this is just to set up the virtual environment. Okay, but we've done this. We've created a virtual environment. But this isn't enough. Just creating it isn't actually going to do anything. In order for Python to know that you're trying to use the virtual environment, you have to activate it. And in order to activate it, what you have to do is you have to type in this command. You have to type in the command source, and then you have to type in the path vnv/bin/activate. On a Windows device, you may have to use the backslash, whatever the delimiter is. But here, I'm going to type source VNV. Remember, this is the name of the folder. So if you called this something else, you would give it that same name, /bin/activate. And if you press tab, it should typically complete. And if it doesn't, then you probably did something wrong, and you may have to delete the folder and rerun this command. But if I run this, you'll notice that something changes about this terminal. You'll see here that it shows here that we're in a virtual environment, whereas here it didn't show it. And because I'm using this specific application, this specific format, it looks a bit different. But on your terminal, it'll probably look something like VMV tester in parentheses somewhere next to your name. That's typically what you'll see, something like this. And once you see that, you know that you are activated. That's basically all you need to do to activate a virtual environment. Okay, so now that we've activated it, you can do the development you need to, do whatever you need to, and once you're done, it's not recommended to keep a virtual environment running. Instead, what you want to do is you want to deactivate the virtual environment. And to do that, it's fairly simple. All you have to do is type in deactivate, making sure to type it correctly, deactivate. And once you do that, you'll notice it's no longer here, so we're no longer in the virtual environment. And that's how you deactivate and activate a virtual environment. It's fairly straightforward in Python, and it just overall makes it Python makes it very easy to set up, create, activate and deactivate virtual environments. Okay, so now let's get back to PyPy. Before we go more into virtual environments, let's talk about the Python package index. So what this is it's the official third-party package repository. Essentially, it has thousands of Python packages that other developers have written, and it's hosted on the website where you can just download them using pip and basically use them to whatever you need to do. Essentially, it's just very useful because there are some things that you don't want to write, and that using code that other people wrote is just a lot easier and it's a lot more time efficient. But what's important is that you should read the documentation and the terms of service of the package, because some packages may have different terms of services, and the documentation is also very important to read so that you understand what the code is actually doing and to use it properly. So that's something that you'll have to do with every third-party package that you use. Okay, so now what is pip? Pip, like I said, allows you to basically just install packages from this PyPy repository. And pip commands are run from the command line. Once again, IDEs typically can help you with this, so you'll have like a beautiful graphical interface to do all this, but it's useful to know how to do it from the command line as well. So what you want to do is make sure pip is updated to the last version, and to do that you could just, if you're not sure, just search up how to upgrade pip, and it's fairly straightforward. And the first thing you want to do is you want to activate your virtual environment. So once again, remember the command source -bin/bin/activate. And once you do this, you have activated. And it's not recommended to run, to install pip without a VMV. You can, and it will work. But the thing with that is it's going to download it to basically your computer. Your computer will have this pip thing installed. But by activating the virtual environment, you're telling Python that all pip installs should be local to this virtual environment. So if you ever delete this virtual environment, it'll delete all those pip installs, which is useful because you don't want to have code that you're not using on your computer anymore. And then once you activate your virtual environment, to install a module, all you have to do is type in pip install and then basically your module name, whatever you want. Again, on a Linux or a Mac device, you may have to run pip3. You'll be prompted if it says that maybe pip is deprecated or if it doesn't work on your computer, then you may have to use pip3 instead. Okay, so what are these modules? What are these packages that you can use? Well, to find it, what you can do is go to the website, pypy.org, and I'll actually open that right now. If I go to pypy.org, this is the website. You can search up projects, search up packages that other people have posted, and basically find stuff you want to use. A very, very common package that a lot of people use is NumPy. NumPy is very good for calculation-based stuff, to do efficient math and stuff along those lines. And so it's a very common stuff common package that a lot of people will install. So what you can do is you can search up NumPy, typically click on the first result, it'll be the latest version. And then at the very top, you can see what it is, latest version, all these information. And then this is the line you care about, pip install NumPy. What you could do is you can copy the clipboard to copy the text, and basically you can paste it in your command line. So here you have your activated, remember it should be activated, and then what you can do is you can just copy, paste that, and run this. As you can see, it'll do some stuff behind the scene, collecting NumPy, it'll do installing the packages, you'll have this thing, and eventually you'll see this. And as you can see, it says I'm using version 19.2.3 while the latest version is 21.1, and it shows you helpfully how you can upgrade it. So if you were wondering how you can upgrade pip, this is how you do it. Pip install -- upgrade pip. That's just how you do it. Okay, so what did that do? Well, if we open up this, and if I go to I could go through all these. I'm pretty sure if it's in bin, Python is going to install NumPy. So, or in fact, Python already installed NumPy. You can find it on your directory if you look for it. I'm not exactly sure where it installs, but you'll find out that NumPy is installed to this virtual environment. Okay, so that's basically it. We've installed NumPy, and now we can basically use it. If we had a module, we can use NumPy in our code, and it would work just like that. Okay, well, what about using third party? So there are a lot of pros and cons for using third-party packages, but in my opinion, the pros outweigh the cons. So the thing with the pros is that it's extremely easy to work with third-party packages because other developers have developed code that basically just makes it easier for you to do certain tasks. It also speeds up development because you do not have to program those repetitive things over and over again. You could just use what other people have written. And typically, good packages will have also good documentation, which usually makes it easy to use, easy to read, easy to understand. However, the cons of third party is that you have less control over the code itself. You don't really have full access to, or you can't really control exactly what's going on. And sometimes that's a problem. Sometimes you will have to write it yourself. But again, I think that the pros far outweigh the cons, and that using third-party packages will speed up your workflow. So overall, modules are just important because you can access functionality that is core to your project, but you're still developing the large majority of it, which is relevant to what you need. It's just that the stuff that you don't want to have to code out, that other people have, you can just use. Okay, so now that we're done with this, we'll take you through a few exercises that review the command line commands on how to create a VMD and how to access these kinds of things. So the first thing you want to do is you want to create a new project, and typically that's just done by making a new folder. Now what you want to do is you want to create a virtual environment and activate it. Try to recall those commands, and if you don't, you could just rewind the video to find out how to do that. What you want to do is you want to create a clef package and a bass and a treble modules. So the clef package should have two modules, the bass.py and the treble.py. And all you can do in that is just print something out. It doesn't really matter what you do inside of that. You can do whatever you want, but this is just to show that you know how to do the format. What you also want to do is you want to create an instruments package, and again with a violin and a bass guitar, or other instruments if you want. And it should have this directory structure, or generally along these lines. And see if you can try to figure out how to access files between these, between each other, and generally figure out how this directory structure is affected by things like the virtual environment. The second thing is you should create a module with basically a function that just randomly generates numbers. And then what you also want to do is you want to create a card class and a deck class. And basically the deck class should just have a random list of cards that are shuffled. And also, just to review your importing, try not to use the import random syntax. Try to use maybe the from import syntax that we talked about earlier in this video. Anyway, those are the exercises. They should be fairly straightforward if you watch the video thoroughly. And that wraps it up for our intermediate Python video.